Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adin Filza binti Cik Muhammad Nur and my student ID is 2021626436.
My name is Nur Aisyah binti Rizwan. My student ID is 2021208656.
And my name is Anisara Umaira binti Muhammad Masri. Student ID is 2021608872.
Now, I will explain to you about work. There are 4 types of work. Work done by a constant force, work done against gravity, work done against friction and condition when no work is done. What is the meaning of work? Work is a scalar quantity and defined as the product of an applied force and the displacement of an object in the direction of the applied force. The first is work done by constant force. When the force and displacement is in the same direction, we use the formula W equal to F multiplied by S, where F is force and S is displacement. For example, calculate the work done when the worker uses a horizontal force of 500 Newton to push the trolley to a distance of 10 meter on a horizontal surface. First, we must identify the force and displacement in the question, where the force and displacement is 500 Newton and 10 meter. Then, we use the formula W equal to F multiplied by S, which is 500 multiplied by 10, and we will get the work is equal to 5,000 joule. Now, what happens if the force and displacement is in different direction? For this case, we must use different formula, which is W equal to F cos theta multiplied by S. Looking at the question, the first thing we must do is to identify the force, displacement and cos theta in the question, which is 150, 27 and cos 45 degree. Then, use the formula W equal to F cos theta multiplied by S to get the answer. Next is work done against gravity. The formula is W equal to mgs, where m is mass, g is gravity and s is displacement. For example, find work done against gravity when a body of mass 10 kg is raised through a vertical distance of 3 meter. In this question, the mass is 10 kg, the gravity value is 9.81 and the displacement is 3 meter. Use the formula and you will get work equal to 194.3 joule. Next is work done against friction. When a body is pulled at a uniform speed on a rough surface, the work is done against the frictional force which is acting on the body due to the contact with the rough surface. Look at the question. For question A, they ask us to calculate the work done against gravity. The formula for work done against gravity is W equal to mgs, where m is equal to 15, g gravity is equal to 9.81 and s displacement is equal to 3 sine 20 degree. For question B, they ask us to calculate work done against friction. First, we must resolve it horizontally, where R is equal to W equal to mg, which is mass and gravity. Then, find force equal to friction equal to mu R, where mu is 0.3 and R equal to 147.15. Then, we resolve it vertically using R equal to W equal to mg cos theta, where cos theta is equal to cos 20 degree. Then, to find the work done, we have to use F multiplied by S, which is 44.15 multiplied by 3, and we will get 132.45 joule. The last one is condition when no work is done, which is object is stationary, or no force is applied, or direction of motion is perpendicular to applied force. If the distance is 0, no work is done even if a force is applied. For example, if you push a wall, the wall will not move even after we applied the force. The second, no work is done if an object is moving with uniform velocity without the action of force. For example, the satellite. And the last one is direction of motion is perpendicular to applied force, which can be calculated by W equal to F cos 90 multiplied by S, and you will get 0 joule. For example, if you are walking while carrying a bag.
Next, we go to energy. What is energy? Energy is defined as the capacity of a system to do work. When work is done, the energy is transferred from an object to another. The amount of work done is equal to the amount of energy transferred. Energy exists in many forms. Some energy exists in forms kinetic, sound, heat, and light. There There are two types of mechanical energy that you should know. One is kinetic energy and second, potential energy. Kinetic energy is ability to do work by virtue of having speed. For an example, a speeding car. Meanwhile, potential energy is ability to do work by virtue of position or condition. For an example, a suspended weight and a stretched bow. Now, we will go detail for kinetic energy. Kinetic energy is the energy of an object due to its motion. When a force does work on a body so as to increase its speed, then the work done is a measure of the increase in the kinetic energy of the body. As you can see this picture, a kid is trying to push the trolley, so there is force acting on the object. Therefore, the object will move forward with an acceleration from at rest. Hence, velocity increase, displacement also increase. Since the work done is transferred to the object as kinetic energy, therefore, what is the formula for kinetic energy? The formula for kinetic energy is 1/2 multiply with m and multiply with v square. M stands for mass, v stands for velocity. Next, we will go through example question to make you understand better how to calculate kinetic energy. Question 1. A cricket ball of mass 350 gram moving at 2 ms minus 1 and a golf ball of mass 150 gram have equal kinetic energies. Find the speed at which the golf ball is moving. The question wants us to find the speed of golf ball is moving. It is already given. Cricket ball mass is 350 gram and the velocity is 2 ms minus 1. Meanwhile, the question only gives input that the golf ball has mass of 150 gram. First, we need to find kinetic energy for cricket ball. We already know for mass cricket ball, which is 350 gram, and the velocity of cricket ball is 2 ms minus 1. Now we will apply those info into the kinetic energy formula. Therefore, we will get 1/2 multiply with 0.35 multiply with 2 square. Why we use 0.35 instead 350 gram? Actually, we have already convert 350 gram into kilogram. Because in kinetic energy formula, we must use in unit kilogram, not gram. For the answer for kinetic energy for cricket ball is 0.7 joule. It is mentioned in the question, kinetic energy cricket ball equal to kinetic energy golf ball. So, both kinetic energy cricket ball and kinetic energy golf ball is equal to 0.7 joule. Now, applied to the formula, we will get 0.7 joule equal to 1/2 multiply with 0.15 kilogram multiply with velocity square. Now we will find for the velocity of golf ball. At the end, we will get 3.055 ms negative 1 for the velocity of golf ball. After that, we look at question 2. Find the gain in kinetic energy when a body of mass 10 gram increases its speed from 300 ms minus 1 to 400 ms minus 1. This question wants us to find how much the body mass gain in kinetic energy. First, we need to find the velocity between two speeds. So, we have to minus the final velocity with the initial velocity. Therefore, we will get 400 square minus with 300 square. And we will get 70,000 ms minus 1 for the velocity. Now, we will apply this information in kinetic energy formula. Therefore, we will get 1/2 multiply with 0.01 multiply with 70,000 for the velocity square.
We got 0.01 kilogram from convert of 10 gram.
Lastly, we will get the gain in kinetic energy, which is 350 joule. After we already know for kinetic energy, now we will go to potential energy. What is potential energy? The potential energy of a body is the energy stored in an object due to its position above the Earth's surface, which is the energy that passes by relative to its position. Look at the above figure. The figure shows there is a crane lifting an object. Work is done to lift the object. The object gains an amount of energy that equals to work done to lift it. The potential energy will increase if work done against gravity. Meanwhile, the potential energy will decrease if a body is lowered vertically. In short, potential energy will increase when the crane lifting the object vertically.
As you can see, height exists
When the crane lifting the object. So, we will get for the formula potential energy, which is mass multiplied with g, gravity, multiplied with h,
height.
After that, we will look at for the question that involves in potential energy. The question is, find the change in the potential energy of a child of mass 40 kg when A, ascending a vertical distance of 4 meter, for B, descending a vertical distance of 4 meter. First, we look at A. We must find the potential energy of a child when ascending a vertical distance of 4 meter. So, we will apply the overall information into the potential energy formula, which is mass multiplied with gravity and multiplied with height. Therefore, we will get 40 kg multiplied with 9.81 and multiplied with 4 meter. Therefore, we will get 1569.6 joule. Meanwhile, for B, the equation wants us to find the potential energy of a child of mass 40 kg when descending a vertical distance of 4 meter. In previous slide, I already mentioned the potential energy will decrease when a body is lowered vertically. So, when descending, the child is losing potential energy. How to calculate loss in potential energy? We will just apply the same formula,
Is mass multiplied with gravity multiplied with height.
we put all the information into the formula. We will get 40 kg multiplied with 9.81 and multiplied with 4 meter. Therefore, we will get 1569.6 joule.
And the last one is power. What is power? Power is a measure of the rate of which work is being done or the rate of using energy. If 1 joule of work is done in 1 second, the rate of working is 1 watt. Hence, a machine that does 1000 joule of work per second is working at a rate of 1000 watt or 1 kilowatt. We can refer to this formula, power equal to work done over time. Although they both mean pretty much the same thing, it is important to know that there are actually two different definitions for power, each with their own equation. One is that power is the rate at which work is done, and this can be written as power equals work done over time. The term work done can be a bit confusing, but basically it's just a special measure of the energy transferred and is used when a force is used to move an object by a certain distance. For example, if you push a car down the road, then the energy that was required will be referred to as the work done as you move it at a certain distance. The other definition for power is that power is the rate at which energy is transferred, which can be shown by the equations power equals to energy transferred divided by time it took to transfer the energy. Whereas, if electrical energy was transferred from a plug socket to your phone, would refer to that as just energy transfers, as there is no force or movement involved. To see how the equation works, let's do some example. Imagine that to push a car down the street, you have to do 9 kilojoules of work over the course of 20 seconds. How much power are you using? Once we have the equations, we can see that all we have to do is divide the work done, which is 9 kilojoules or 9000 joules by the time taken of 20 seconds. So the power would be 450 watts. Let's now try another example. If an 1100 watt microwave is on for 3 minutes, how much energy is transferred? First, we need to take our energy transfer equations and rearrange it to get energy transferred by itself. If we put the equation into a formula triangle like this, we can see that energy transfer will be equal to power multiplied by times. We also need to change our 3 minutes to 180 seconds by multiplying it by 60. And finally, we can substitute our values into the equations and do 1100 times 180 to give us 198,000 joules. And whenever we have a big number like this, we can convert it to kilojoules by dividing it by 1000. So, we will have 198 kilojoules as our results. Now we know the difference equation between two powers. Let's move to a harder questions. Each of the diagrams below shows a particle moving along a straight wire under the actions of a constant force. In each case, the particle travels the length of the wire in 5 seconds. Find the work done by the force and the average rate at which the force is working in each case. For question A, first state the value given. Force is equal to 9 newtons, displacement is equal to 20 meters, and time is equal to 5 seconds. For solutions, we can find the work done by multiplying the force with displacements. So, 9 Newton multiplied by 20 meters is equal to 180 joules. And to find the rate of working equals to work done divided by times. So, 180 joules divided with 5 seconds equals to 36 watts. For question B, state the given values. Force equals to 30 newtons, displacement equal to 10 meters, and the angle is 60. For the solutions, work done is equal to force cosine theta multiplied by displacements. So, 30 cosine 60 angle multiplied by 10 equals to 150 joules. Lastly, to find the rate of working, it equals to work done divided by times. So, 150 joules divided by 5 seconds equal to 30 watts. In conclusions, a good understanding of these concepts can help in analyzing and designing various systems, from simple machines to complex systems such as power plants and engines. This is because work, energy, and power are closely related concepts in physics that are important in understanding how different systems operate. Work is the transfer of energy from one system to another, typically through the application of a force over a distance. Energy is the ability to do work and comes in different forms such as kinetic, potentials, and thermal energy. Lastly, power is the rate of which work is done and is measured in watts. These are the references that you can refer. That's all from us. Thank you.